Hello, I'm Stella, an application engineer from Izumi. I'm so glad that I have the opportunity to introduce Director Pro to you. Director Pro is long fiber director injection modeling process, and later I will call it DIM. Today's presentation will be delivered into 4 parts. The first part is fiber reinforced plastical. It's going to be some basic knowledge and concepts. It's about the background of our director injection modeling process. And for the second part, it's director approach. I will focus on our injection molding machine with DIM system. For the third part, property of long fiber reinforced parts. It's about final products, about the fiber legs, and mechanical properties. What tests we can do for these reinforced parts. Finally, it's about current activities with Director Pro. It's about marketing our application. I will come up some typical industry market or products to show with you. So let's go to the first part. We are going to talk about fiber reinforced plastical materials, compositions, process, classifications, and what most important in here is the reinforced. I will talk about how are they reinforced material. So maybe you can see in this page, somebody would maybe ask me, what is fiber reinforced plastical? You can see here is the 3 components of the fiber reinforced plastical. The first one is fiber. The second one, polymer, the plastical, and we need to add some additives. Here for the fiber, what we can choose is organic fiber, inorganic fiber, natural fiber, and mental fiber. During this presentation, we are more focused on glass fiber, the inorganic fiber, and I will talk a little about carbon fiber. For the polymer, at the beginning, I see it's Director Pro is for the injection molding machine, so we will focus on thermoplastical. And what about the thermoplastical and the glass fiber additives? It's colorings, fairings, like that. And you can see here we have so many very huge thermoplastical tabs. Why we need fiber reinforced plastical? That's because maybe we want to get some special properties like mechanical properties, thermal properties, and also in some situation we want to use plastical in place instead of metal materials. And also from the designer, we want to have lightweight. We have calculated for the energy and the economic reasons. We want to use some cheaper material with fiber, not very high cost of thermoplastical, like we want to use PP with glass fiber instead of PA66. This also obvious. And we talk about what is fiber reinforced plastical. We need to imagine in your hands, you have fiber, you have polymer, and you have additives. This means you have the fiber reinforced plastical. Obvious not. They are separate. How we compounding or how we mix for these 3 components, we can get the fiber reinforced plastical. Always we need this middle step. We need compounding, partials, interfractures. And we get some pellets or some middle materials. We can go to the other step. We can get the final part. We need to use injection molding machine. We use extruder machine. We use compression molding machine. So during the middle process, like compounding, we can get some pellets, like short fiber pellets. This means the fiber, what the three types pellets or products different is defining for the fiber length. For the short fiber means the fiber is 0.4 to 0.8 millimeter, and for the long fiber, it's 8 to 25 millimeters. And for the semi-finished products, this is GMT or organic shape. We always calculate for this parts fiber length is endless fiber, or we can call it continuous fiber. And like this pattern length, this is just the middle product. If we want to get the final parts, final products, or the set, the chair, what the customers buy from you side, we need injection molding, we need extruder, we need compression molding. So this is not the direct process because we have the middle process in here. For Izumi, for direct pro, what means direct process is we skip. We don't need this process. We don't need compounding. We just have three components of plastical and we go to the injection molding. This is what the direct pro, the real meaning. Here, we can talk more about the legs of fiber because later we'll show the legs have important difference of the properties of parts. Fiber reinforced semi-plastical. According the legs of fiber in the plastical can be delivered into short fiber reinforced semi-plastical. You can see here fiber legs generate 0 to 1 millimeter, and the average length is less than 1 millimeter. And for the long fiber reinforced semi-plastical, we calculated the fiber length is generally more than 1 millimeter. And also we have a limit. As before, the limit is 10 millimeters. We should think this is the limit for the long fiber. But now in the situation, we have the pellets we can produce by the compounding or pressures. They can be 25 millimeters. And also the other step is for the continuous fibers reinforced semi-plastical. For the fiber materials, it's many including for the glass fiber, carbon fiber, and small types of metal fiber. For plastic material, this includes a variety of common plastic, engineering plastical and high temperature plastical. As I informed before, it's PP, PA, PC, ABS, or some mixture of ABS, PC like that. And also for the direct process, we can use recycled materials. It's also work. For here, I want to talk more about for the polymer because this is more common for you. If we choose PP as the polymer, we add some fiber to reinforce. Always we have some our requirements. That's why I list in here is high stress. This is mechanical properties, high resistance, low warping. That if we use fiber reinforced PP, maybe you can instead of this material of PA, the cost we can decrease for the material. And for the PA, we also have high requirement. We want instead of metal parts like high tolerance and creep resistance, and also low warpage. Because for if you add some fiber, the dimension stability is better than just have the polymer. And also we talk about PU, PET, or PPS with the mix of fiber reinforced plastic. We also focus the same point is high tolerance, the long warpage, and also for the product appearance. before this topic, I would like to ask both of you two questions, because I think it's hard to imagine about fiber reinforced plastic, how it's reinforced. So I want to find a real life example. The first question is that, have you had the experience of decoration your homes? And have you, the other question is that, have you all seen the reinforced concrete as before? Not just the picture, that in the real life, have you seen this concrete before? I think almost of you maybe have this experience. That for here, you can see in the left side here is the stair, or we can call the stair a bus or stair structure or like that. And here is concrete. You can see in the right side here is the fiber, and here is our plastic or polymers. I think in the reinforced system of concrete system and polymer system, it's like the same. The fiber acts to absorb the engineer of values in the reinforced system, similar to the steel in the concrete, which enhance the mechanical properties of material via maintenance, similar deformations, and dimensions stability of the product. So as this clarifies, I will go to the next step. This one is very common graphic when we talk about fiber lags influence about the mechanical properties. So what can we learn from this graph, from the three curves? I think we need to look at into three parts. First is here. I call it short fiber. And here is long fiber, and here is continuous fiber or endless fiber. We can calculate for the three curves. When the fiber lags from the 0.1 millimeter to 1.0 millimeters, moderate increased, you can see here, these curves, moderate increased by 125%. And the stress here in the middle, the stress increased by 25%. It's not very obvious than the moderate. And for the impact, increased 200%. So we can go to the second period. The lags from 1.0 millimeter to 10 millimeters. For the models, you can see here, they just increased 10%. But for the stress, increased by 80%. And for the impact, it increased more than 150%. And with the glass fiber lags increased, you can see in this period, the modulus and the stress do not increase very obvious. Just the impact you can see only here is increased. So what we can get these curves or graphs, I show here. Fiber is reinforced materials and can bear stress. It's very obvious. So you can follow the curves increased here, moderate stress and the impacts. And also fiber lags have great influence on the performance. Yes, follow the increased, no problem. And in a certain lags range, the mechanical property of products are improved with the increase of fiber lags. I think this certain lag range is from 0.1 to 10 millimeters. And however, it's not that the longer the fiber lags is, the higher of mechanical property of products. You can see when the lags is reached 10 or we can go to the 100 millimeters. The improvement of effects mechanical property of products is not obvious, and even some properties will decline. So from this part, I think it's very clear. Long glass fiber or long fiber, okay, we can have a good mechanical properties. But I want to highlight for this one, it's do not blindly pursue fiber lengths. Enough, we just focus what means enough. Maybe for this part, for the models, you just your requirement is here. So means maybe 5 millimeter length is suitable for you. So we just calculate 5. We don't need to match 10 or 12 or 20 like that. So for these groups, I think we have talked more about this table and talk more about the fiber lengths. So what else do we need to focus on besides this table or besides grapher? Please look at for the right side. I make a list. There are a lot of things that we need to focus on. I would suggest that you focus on like fiber type, glass fiber, carbon fiber. These have a big difference between. And for the material, for the polymer, PP and PA6, PL66, what is the difference? I think I don't need to clarify again. And the other, it's not, maybe you not met before for the common injection molding process. But for the DRM, you should focus. For this one, it's fiber polymer adhesions. Thus, we will focus. And here, also fiber content. This is the same function like fiber length. For the injection molding process, temperature also is very important for us. I think that before it's enough about we talk about fiber, we talk about scenery. So we get back to the process itself, and let's look at what can DRM, what can direct pro bring to you, to our partners, to our customers. You can see here we have 3 components, and we skip the middle process. We just go to the direct injection molding. And from the material side, what we can get from the director. The first thing is for the cost saving by the direct process, because you don't need to pay for the middle process. And for the compounding, can be adjusted by yourself, by the worker, and the material know-how. This is what experience component for the material cost. It's in your side. Also, this can preserve of long fibers because we skip for the middle step. We don't need to calculate this step. We will cut for the fiber. And for the whole process, we can look here. We can get the simple plastic parts with high requirements because here we can reserve the long fibers and the continuous produce parts, large parts, high capacity investor. Also, it's a possibility that we can combination of compressors and injection molding machine with extruder or compounding. So here I will calculate for one example. Take an example with PP 30% glass fiber. If you buy the PP from the market, you know the price is no more than 1.4 euro per kg. And if you buy the glass fiber rolling, you can get maybe 1 euro per kg to 1.35 euro kg. And for the additives, because we have so many different additives maybe we will use. We just make an average. We think the percentage is 4%, and the price is 3.5 euro per kg. And compares what the polyaments you buy from the market. For the 13% glass fiber, if short glass fiber, you can buy no more than 2 euro per kg. And for the long glass fiber, maybe the prices is high, maybe, but no more than, I think, 2.65 euro per kg. But if you get the material direct by the DRM system, by the direct processant, the material cost is 1.76 euro per kg. I think it's obvious. All know how to do the add and delete. And this page we will talk about our machine and the fiber. The first, our machine is not a very special machine. We are based on the standard injection molding machine. We just modify for the cylinder unit and add for DIM system. It's very simple to set up and low system cost. For the scalability and upgradability, what I need to highlight is for the programming and the monitoring and the documentation. It's in the same machine control system. For the Direct Pro, we just add a separate page, the control page. For the DRM system, you can control the fiber content, the fiber speed, like that. And turn off or turn on the DRM unit. And also for the machine, you can still usable for the standard injection modeling task. From the fiber sides, you can cut the fiber in the defined lengths. And any fiber contains, it's up to your fiber speed. I will show you the radius and some picture about that. And you can change the fiber content during the running production process if you want. Also have incorporation of fiber at a location where the polymer already is metal. Here is because when we're fading, or the position we're fading the fiber is in middle of injection units. That's for the injection cylinder, is middle of this one. I can show the photo later. Maybe you can have a clear concept. And also we can get the final part property is better than retrievable with the long glass fiber pen length. Also for our process, you can use any kind of fiber rolling. Not just glass fiber, also you can use carbon fiber, even some metal fiber. So I think the first part of the presentation is all about on the paper. Now let's look at about the actually machine, photos, radios. And this part, first part, I will show you the glass fiber. Let's look at the picture. The left side is your fiber that you can buy from the market, the chopped standard fiber. And the right side is our fiber, is DRM fiber, that chopped by DRM system. Always, if you buy from the market, you can get the fiber length is no more than 7 millimeters. And from our side, by the DRM system for the length of glass fiber or just the fiber, it's 5 to 100 millimeters. Here you can see it's a graph for our DRM system. Maybe you can see my mouse. Here is the chopper to cut the fiber rolling. Here is the side fader to fading the fiber. So operator, you can see the first step, we will chop the fiber straight directly from the rolling into the fed section of the side fader. Means here we go to the rolling and cutter, drop down to the friction, feeding section and dry conveyance to the chopped fiber into the process machine. Process machine here means injection molding machine. We will connect with injection cylinder here. And we have a special shape feeding open. This is secret for Izumi. And airflow supports feeding on this fiber in here, in this position. And section of fiber fragments and particle, and close set up for avoid particle emissions. Okay, I will show you the actual picture. Here is not mentioned in last page. This is broad priming. It's storage for the rolling, and we can monitor for the fiber legs. Here it's for the airflow or vacuum unit. We can give the support for the side feeder. Here is the small one. It's in here, the black one. It's fiber cutter. And we go to the side feeder. It's not just this area. It's this big area, the blue machine. Its whole means side feeder. I think the picture maybe not clarified, so I have a radius for you.
Direct injection molding processing has been developed based on Izumi's standard injection molding machines by using combination of an dim barrel assembly and a dim system that has glass fiber strength cutting and meter feeding feature. The dim system control is integrated in the injection molding machine controller, providing easy parameter settings and operations. Users may customize the fiber length, fiber percentage, and material combinations according to their needs through the dim system control. The polymer consists of standard PP granules to which the fiber is added during processing. The fiberglass strand is cut by the dim system during the plasticizing process and added directly into the PP mill to produce fiberglass reinforced product. There is no need to use pre-compounded PP glass fiber modified material. During the production process, the glass fiber percentage may be adjusted in real time through the control system of the injection molding machines to change the proportions of the compound. The presence of long glass fiber increases product strength and toughness. Impact resistance is slightly lower than GMT, but significantly higher than LFTG as it has longer fiber length and better fiber network effect than that of LFTG after molding. One-step production reduces the manufacturing and logistic costs of raw material. The entire production process includes only one heating stage, significantly reducing energy consumption compared to pre-compounding material. The cost of raw material drops by 30 to 50 in comparison with LFTG and GMT. Long or short glass fiber reinforced composite materials are primarily used in structural and functional automobile parts, such as front end support structure, dashboard frame, spare tire rail, car seat frame, and auto chassis guard, etc. Fiber reinforced polymers are widely used in construction foam work. Base support for environmental products, packaging containers, theater and sports pavilion seats, shipping containers, and pallets. As an example, the current domestic price for natural PP is 9 yuan per kilogram and 7 yuan per kilogram for fiberglass strand. The market price for PP glass fiber 30% for short glass fiber is 15 to 20 yuan per kilogram. For long glass fiber is 20 to 30 yuan per kilogram. The price of the raw material, PPD long glass fiber 30% made by our dim process is 8.4 yuan per kilogram. This offers huge cost saving and the added benefit of being able to make a compound during the component production process.
So I think after these videos, maybe you can have a clear concept of our director DRM process. And we go to the third part, the property of long fiber reinforced parts. For this part, we will talk about fiber length determination and the mechanical properties. We are more focused on what types of tests you will use for these two constraints. First one, you can see the test bar for the tensile test. We will choose this part to calculate for the fab length determination. What we do is we will choose 3 different positions from the sample. The first one is near to the screw here. You can see the structuring here. And the middle and far from the screw, because we want to know in the different position the glass fiber length is different or the same. And here you can see after the FASEP analysis, we can get the length of fiber during the different position. We can calculate for the length average and the width average. And for this one, it's for the tensile test. You can see the tensile bars we use for do the length determination before. And you can see after test the tensile, we can get this page. It's more similar to the steering the concrete, right? Also here we have the menus. You can see the length of the fibers, just the rough. And you can, after the tensile test, you can get these tables in here, because for this one we will test for during different test speed, and for the test temperature it's always room temperature, and we can get what we need is for the tensile models and the mass stress. After the tensile test, we can get what is important for us is for the tensile models, we can compare with the market balance by maybe from Kinfa or other supplier. And after the tensile test, we will do the impact test. For always we can do is for the not touch the bars for the impact test. Because for the impact test, we have different machine. I just put one in here. After impact test, we also can see fiber in the broken parts. It's very clear in here. And we can get the impact test result like this table. And what is important for us is here for the impact stress. If we have these numbers, we can calculate, we can compare with the marketing material we buy before. So that's all 3 types of tests that we can do for the director process. And if you have this requirement, you can ask Izumi to supply this report to you with the glass legs, with the fiber legs, and the tensile test, the impact test we will provide for you. For the last part, it's for the current activities with Director Pro. For this part, the first I will talk about the background. It's more like for the lightweight of automobile industry. And the second one is application, what we can use director process. Okay, for the first background, I choose it from the automobile industry audit A6, the 7th generation model weight change process. We can follow the curves in here. the number is clear in here. The weight is increased because of the safety, comfort, and function requirement. The car's weight is increased, and increased. But during in the 2000 years, just 20 years before that, for the economical and for the environment reasons, we want to have a lightweight process. So you can see during now for the 7th generation model, they have decreased for the weight. And this is the trend in the future. Also, we can see the trends in the use of plastic or composite in the automobiles. That because you see here, we want decrease for the weight, but for the safety, for the comfort, for the function, we can't delete. We need remains for this requirement, but we need lightweight. What we can do is that for the material. At the beginning, you can see as before that, we use almost a steel in the cars, but it's decreased step by step. Now it's 33% steel and 13% the same of the plastic and the composite. For this part, more and more plastic used instead of steel means they need high mechanical properties. What we can use is fiber reinforced plastic. So for Izumi, what we can use is injection molding machine with director probe because we can have the cost saving in the material. Here, for the application, you can see in the automotive components what we can use. This is not the whole part. I just have some short breath for this one, maybe dashboard carrier and front end assemble carrier and some shears. This is function and the structure parts we can use fiber reinforced plastic. I would like to, before, I would like to come up one part to clarify. For this part, it's front end models. The picture is from the Polar cars, and compared with metal, it's 24% less weight. So what is the history for this part? In 2003, the world's first PP with long glass fiber front end models was installed in the Mazda 6. The entire front end models, which is as just 3.5 kilograms, you can imagine if we use steel, it's maybe almost 4 to 4.5 kilograms. Thus, it's the beginning of formal application of long glass fiber in the front end models. According to the market data, we can estimation for the global growth rate of practical front end models. It's 6%. And at the present stage, what is the market of front end models? 40% they still use metal material to produce front end models. And we have 25% they use PA6 with 30 glass fiber and add some metal to mix as composite, or PA6 with 30% glass fiber. And we have 35% market is use PP with long glass fiber. Maybe glass fiber component is 13% and 40%. That's a good news for us. We have this big market in here. And for this one, at the beginning, I see this first is in 2003, and after more than 10 years of development, has been regularized by more and more OEMs. including Chinese automobile manufacturing such as Geely, Great Wall, Guangzhou Automobile, Shanghai Automotives, and other OEMs, have started to use long glass fiber products in replace the traditional metal and PA front-end models, because we have a big advantage of metal material cost. You can see here, from the point of view material, it's mainly to ensure long-term thermal agents properties and the modeling properties. So it's very necessary to add optimized thermal agents activities in the recipe. At the same time, we know this part is around engineer. So means PP with 13 or 50 long glass fiber with heat resistant edges is generally selected. Take 40% long glass fiber as example. Material requirements are as follows. You can see here is high stiffness, the model's lamp. And also they have high thermal deformers temperatures, high toughness, impact stress. Also, we have long-term heat agents in different temperature. So that leads to many materials enterprises do not have the ability to develop to this kind of products. At the same time, the thermal agent cycle is generally 1,000 hours, we can see in here, for high temperature. And the evaluation times is long here. So many OEMs cannot quick judge which its reliability material met this requirement for long-term agents when choose material. In order to issue good modeling machinability, it's necessary to choose PP with high fruit and which also reduce the molecular weight of the material to certain extent. So this is for the material choose. What we are focused on for this part for the front-end models. And for the models, what we need to calculate. In aspect of models, I highlight in here the size, the angles of nozzle, the runner, the gate, corner, and other places need to optimize to issue the length of glass fiber in the final product. Because of glass fiber can be cut with the floor and high shearing fiber legs, and maybe after this they can meet the design requirements of the final products. According our experience, to determine whether the legs is reached, the usually protects its cut different parts to the different position. Bird then and test the average length of remained glass fibers. That's what we do in the third part. And for the dashboard farming, we focus on for the dimension stabilities. For the door modelings, we focus also for the dimension stabilities, and we want to have cycle times. For the real heat structures, we want to compare with metal if we use plastic. For the first frames, it needs to install in structure of instruction panels, which requires high stiffness. And for this one, we want they have high stiffness and dimension stabilities. At the same time, this airbag also needs to be installed to meet the plastic requirement of airbag that the low temperature and high temperature, the situation for them. So therefore, it's also a safety part for the one. Here it's also a safety part and requires high impact toughness and high low temperature resistance. For this part, we want the high stiffness, dimension stabilities, and also performs they need to standard or suffer for high and low temperature resistance, impact tolerance. So which improve of living standards, the requirements of interior decoration are more high grade, the use of soft structure more and more. And now we can get from the market that they use PP with EPDM and 13% glass fiber. Instead, but in here structure is reduced. They want the glass fiber legs left is 2.2 millimeter to 3 millimeters to realize the lightweight of product. This is very important. And also for furthermore improve the material properties, reduce weight and improve dimension stabilities and low warpage. Now some OEMs introduce a chemical forming process with long glass fiber. And for here part, it's also very main component for the metal structure. We always in China we use metal parts, not plastic part. But foreigners such as Nissan and BMW has gradually adopted long glass fiber plastic or rear tiled door technology because the plastic they can include two parts, out plant and inner plant. They use glass fiber reinforce the plastic 30% to 40% long glass fiber and use adhesion technology between two parts to ensure the structure and appearance requirements. So if both of you, our customer or our partner, you can have this, we can use our process in like these parts. Here also, besides of automotive industry, we also can use our part in the building template. You can see this part is very huge thickness and it's very huge. If we can decrease the material cost, it's a big benefit for this one. And with fiber reinforced plastic, we can remain for the mechanical properties, but we can decrease the cost of materials. For here is industry equipment basis, because for the basis they have suffer some weight, so they have the impact stress, high stiffness and high impact stress. This is what fiber reinforced parts can offer to them. Also for the packing case, for the sets, because always now this is use the compound panels with long glass fiber or short glass fiber. We can, instead of these panels from director process with the same with the same properties. And also for the trial, they have the weight storage, weight suffer, and they use always its PP with long glass fibers. That's our opportunity to use this. That is all about the application of Direct Pro. Of course, there are more occasions we can use DIM process, and we have to work with you to development. That's all about my presentation today. Thank you very much for your listening. And if you have any questions, please feel free to contact with me. And wish you have a wonderful days. Thank you.